This is Advanced Math, Unit 5, Lesson 6. Solving trig equations. Solving trig equations. Okay, find all values of x such that x is between 0 and 360. I'm going to write it like this. So this is going back to the last unit, the unit 4, I believe it was. Thinking back, even further back, unit 3. It was back to unit 3 when we did the, well, let me show you. It makes more sense if I write it down. Number 1, sine of x equals negative root 3 over 2. Okay, so this is going back to where you're working backwards, but the difference is, well, the difference from this one and the last unit is we will go back to 2 answers like we had in Unit 3. Unit 3 we had 2 answers. Unit 4 we did the arc and inverse where we were restricted. Now we're going back to the 2 answers again. We're no longer with the restrictions. You're only going to use those restrictions when you see the word inverse or arc or it has a little -1 sign. This is just regular find your 2 solutions. Okay, so how do we do that? Unit circle, hand trick, whatever works for you. First, recognizing first what is your reference angle. Sine what angle equals root 3 over 2. It is 60. Is 60 degrees one of our answers? It is not because we're not in quadrant 1. So which 2 quadrants is sine negative? It's quadrant 2 and quadrant, and I'm sorry, that is positive there. Quadrant 3 and 4. So what you have to do is figure out what 60 degrees is in quadrant 3 and quadrant 4. And that is 240 and 300. Now, what I wanted to remind you about earlier is that you are using 0 to 360. And if you look at your inequality markings, the equal sign is with the 0, but it is not with the 360. What that means is if you are at your 360 mark and you put 360 as an answer, it is wrong. Again, if you're at your 360 mark and you put 360 as an answer, it is wrong. That is because if you look there, it's not equal to 360. It's equal to 0. So it's all solutions between 0 and 360 equaling 0, not equaling 360. So one more time. If you're at your 360 mark, don't put 360 as the answer. You'll get it wrong. You have to put 0. Okay, moving on. Number 2. Cosecant of x equals 2. And I'm going to make that a -2. Cosecant of x equals -2. So you're thinking here, what's my reference angle? Sine of what angle is 1/2, ignoring the negative, and cosecant's the reciprocal of sine. Sine of what angle is 1/2, and that is 30 degrees. Again, unit circle of a hand trick, 30 degrees, sine is 1/2. Is 30 degrees going to be one of the answers? No, it's not, because it's negative, which means we're not in quadrant 1. Cosecant's the reciprocal of sine, and sine is negative in these 2 quadrants here. So 30 degrees in these 2 quadrants will be 210 and 330. Number 3, square root of 2 times sine of x plus 1 equals 0. Now here you have a little more work because you have to get the sine x by itself, and it's just like what we've solved in the past. Subtract 1 from both sides. Square root 2 sine x equals -1. And then your next step will be to divide both sides by the root 2. Gone. Sine x equals -1 over root 2. Okay, so thinking, sine of what angle? Ignore the negative. Sine of what angle is 1 over root 2? And I'm hoping you're recognizing that it's 45. And 45 is not going to be an answer because it's negative, which means I'm not in quadrant 1. Sine is negative in these two quadrants. So you have to find 45. What is 45 degrees in quadrant 3? And what is 45 degrees in quadrant 4? That would be 225 and 315. So this should feel like review. Really, the only new stuff is you're moving things around, which isn't something we haven't done. On the test, the Unit 3 test, they looked like this or this. Now we're going to be moving things around, factoring, and so forth. Okay, secant x plus 2 equals 0. Subtract 2 from both sides, leaving me with secant x equaling -2. Secant's the reciprocal of cosine, so in your head you're processing cosine of what angle is 1/2. Ignore the negative. Cosine of what angle is 1/2. And I'm hoping you get 60 degrees. 60 degrees, cosine is 1/2. Is 60 degrees going to be one of our answers? It is not, because it's negative. And where is cosine negative? It's negative in these two quadrants here. Remember, you're all students take calculus. It's negative in those two quadrants, so you have to find 60 degrees in those two quadrants, which is 120 degrees and 240 degrees. Okay, number 5. 3 tan squared x minus 1 equals 0. Okay, your basic solving steps, you're going to add 1, 3 times tangent squared, x equals +1, divide both sides by 3, tangent squared of x equals 1/3. Now with that, I need to solve for tangent, not for tangent squared, so we're going to square root both sides. Positive tangent of x equals, don't forget when you square root both sides you have to do plus or minus. So you do plus or minus, square root of 1 is 1 over root 3. Now the tricky thing about this one is it's plus or minus. Before we even address the plus or minus, tangent of what angle is 1 over root 3? Check your unit circle, your hand trick, or your head if you have all the facts in your head already. 30 degrees because y over x is 1 over root 3. Now, is 30 degrees going to be one of our answers? Yes, because it's asking you for plus or minus. Which quadrants is tangent positive? When you look at all students take calculus, it's positive here and here. But I also have it negative, and it's negative here and here. So I'm going to have all 4 answers, 30 degrees in all 4 quadrants. And that happens sometimes. 30 degrees, 150 degrees, 210 degrees, 330 degrees. 30 degrees in quadrant 1, 30 degrees in quadrant 2, quadrant 3, and quadrant 4. Number 6. 2 sine squared x plus 1 equals 0. I would suggest at this point, since we've done enough, you put it on pause, try it on your own, subtract, divide, and get your answer, square root both sides, and see if you can figure it out. Okay, subtract the 1. 2 sine squared x equals negative 1. Divide both sides by 2. Sine squared x equals negative 1/2. Square root both sides. And oh no, we run into a problem. We don't use imaginary numbers when we're dealing with these trig type problems, and we can't take the square root of a negative, so that means there is no solution. No real solution. Okay, why is there no solution? Because you can't take the square root of a negative. All right, I'm going to move on. Number 7, 2 cosine x minus 3 equals 0. Now I'm hoping by now you can do it on your own. Add the 3, divide the 2. You end up with cosine x equaling 3/2. You can put it on pause and show your work if you'd like. Add your 3. 2 cosine x equals 3. Divide your 2. Cosine x equals 3/2. Now, that's not in our unit circle. What do we do when it's done in our unit circle? You draw a picture. So go ahead and draw your picture. I'm just going to draw it in quadrant 1 since it's positive. And cosine is adjacent over hypotenuse. And I'm hoping you're stopping there and like, what? That doesn't make any kind of sense for the hypotenuse to be smaller than the leg. The hypotenuse should be the largest side, so there is no solution. Now I'm going to show you quickly another way you could have figured this out. Before I do, one more time, cosine is adjacent over hypotenuse, and the hypotenuse should not, the leg should not be bigger than the hypotenuse. Another way to think about it is with your sine graph. If I were to graph, excuse me, if I were to graph cosine of x, and let's see, actually I'm going to graph this one right here. If I were to graph 2 cosine x minus 3, that would have a vertical shift of down 3. 1, 2, 3. And it would have an amp of 2. So this is negative 3. Going up 2 puts me at negative 1. Going down 2 puts me at negative 5, which means my graph is going to oscillate between negative 1 and negative 5. Is it ever going to hit the 0? No. It's going to oscillate forever and ever and ever between negative 1 and negative 5. It's never going to hit 0. So on the test, I probably would have given you this graph and asked you something like on the Unit 3 test, and asked you what are the zeros, and you guys would have asked, do you mean the fake zeros or the real zeros? The real zeros. There are none. There's no solution. All right. So up to you on how you do it. You don't have to graph it. If you can look at this and say that doesn't make any sense, no solution, or you think of it graphically and you say, hey, it never hits the x-axis, no solution, it's up to you. All right, number 8, secant x cosecant x equals 2 cosecant x. Now remember from Math 3, in order to solve or move or factor or anything else, we need to get it to equal to 0. Because right now there's nothing I can do. I can't square root both sides, so I'm going to subtract this guy over. Secant x, cosecant x, take away 2 cosecant x equals 0. And then I'm hoping you recognize that there is a GCF. Cosecant x parentheses secant x take away 2 equals 0. And then zero product property. Cosecant x equals 0. Secant x minus 2 equals 0. Add your 2 over. Secant x equals 2. All right, thinking of this one, cosecant x equals 0. 0 over 1. Cosecant's the reciprocal of sine. So this is saying that sine, when is sine undefined? Because the reciprocal of 0 over 1 is 1 over 0, and that is undefined. So cosecant of x equaling 0 is equivalent to asking you, when is the sine of x undefined? And it's never undefined. So this piece right here, there's no solution. That doesn't mean no solution is your final answer, because I may have a solution on my second piece, but this piece right here is no solution. Now, you could also think of it graphically. Cosecant x equals 0. If you were to think of the graph, when does cosecant x equal 0? Cosecant was the reciprocal of sine, so it was the one that did this, and were those U shapes. And we did talk about this in class. When do those U shapes ever touch the x-axis? They never do. So when is cosecant equal to 0? Never. It's never going to equal 0. Here's the 0 right here, and you can see it never touches. All right. Well, we still have to continue because there's this part here. Secant, that's the same as saying when is cosine of x equaling 1/2? When is excuse me, cosine of what angle is 1/2? 60 degrees. 60 degrees. Cosine is 1/2. Is 60 degrees one of our answers? It sure is, because it's positive, which means it's in quadrant 1. Cosine's also positive in quadrant 4. Now we're not using the restrictions of negative 90 to 90 anymore. It's 60, you go all the way around, and 300. Okay, again, we're not using the arc or inverse sine and cosine business, so we don't use the negative 90 to 90. All right, number 9. Sine squared x equals 3 cosine squared x. All right, I'm going to do the same thing I did on this one here. There's nothing I can really do here, so I'm going to get the trig functions off to one side, subtract to get the trig functions together. So I'm going to subtract them over. Sine squared x take away 3 cosine squared x equals 0. Now there's no GCF here at all, but I can use one of my Pythagorean identities. It doesn't matter which one you change. Personally, I would rather change the sine squared, only because it's easier, where this one there's a negative 3 in front that I would have to distribute, and I don't want to worry about distributing a negative 3. So I'm just going to change the sine squared. And what does sine squared become? 1 minus cosine squared. So recognize that these two things are exactly the same. Sine squared is 1 minus cosine squared, and the rest of the equation is minus 3 cosine squared x. Okay, there's not a GCF, but there are like terms right here and right here. 1 minus 4 cosine squared x equals 0. Do you guys see how I got that? -1 cosine squared, -3 cosine squared is -4 cosine squared. Now that it's down to just one trig function, cosine, I can isolate it by subtracting the 1 over, leaving me with -4 cosine squared x equaling -1, and then dividing by -4. Cosine squared x equals +1/4, because the negatives cancel out. All right, and then our next step is to square root both sides. Cosine x equals, don't forget your plus or minus 1/2. And that is something we can handle. Cosine of what angle is 1/2? 60 degrees. And plus or minus means that it is in all 4 quadrants. There's 2 quadrants where cosine's positive, 2 quadrants where cosine's negative. So 60 degrees, 120 degrees for quadrant 2, 240 for quadrant 3, and 300 for quadrant 4. And that is it for this lesson.